Okay, hello, Robert here again, and welcome back. This is module 7. It's going to be a pretty short one. We'll skip a quiz on this one. But so these three sort of techniques or approaches to testing, black box testing, is not something we're going to go in depth on, but it's important that you know about them because these are things that you will actually see in industry being used, and in particular, it's being also some of them are proposed as important by consultants that you will see. There's a lot of consultants doing talks about testing. James Bach, Cem Kanier, others. And these things are also connected to exploratory testing, which is quite a well-used technique today in industry. It's like a high-level system testing, more free approach to testing. And we will get back to that in the part 3, the more advanced and recent modern techniques. But this module 7 is the final one for sort of the basics. So these are things, up until now, these are things that's been classical, used a lot, what you will see also in industry, and it's important that you know about these different techniques. So, requirements, risk, and scenario-driven testing as an overview. Requirements-driven testing, you can hear it from the name, right? You're going to use the requirements documents and the requirements that are available for the project to drive the testing. So you're going to start from the requirements and ensure that you have tests that relate to all of the requirements. That's the goal. Depending on how many you have and what form they have, this can be easy or hard. So the general goal is to validate whether the software product is functioning correctly and meets the requirements as they've been specified or written down. So these are, of course, many techniques that can do this, and they will also differ depending on the shape and form and how you've written down requirements, and you know how manual or automated requirements-driven testing is going to be depends on what form or shape is your requirement specification. I would say the most basic thing here to know about requirements-driven testing, and this is something that you will need, and you will meet this in software companies, is the traceability matrix. So this is a way to trace from requirements to test cases, right? So this is a critical techniques in all requirements-driven testing in some sense. So I'm just going to go get a little bit more into that in the coming slides. Risk-driven testing is related, but it's not only starting from the requirements. So requirements is often a prerequisite, an input to risk-driven testing. So you need to understand the requirement well. And then what you do is that you focus on identifying the main risks that could lead to failure of the project or primarily failure of the system. So you focus the testing based on where the most risky areas are, right? So I first identify the risks, judge or analyze how likely they are to happen and what are the consequences if they would happen. And then you use this to drive, prioritize, or focus your testing, right? So risk-driven testing here is related to requirements-driven testing because you need an in-depth understanding of requirements of the domain, of the system, of the setting in order to do the identification of the risks, right? So it is kind of a follow-up or a complementary technique. But of course, you can use other way. You can analyze and understand the risks from other input than only the requirements. So it's not a one-to-one with requirements-driven testing. It's often an add-on or a complement to, but it can also be a technique in itself. And for example, in reliable software, safety critical software, there are whole techniques about analyzing the risks, analyzing what could lead to a failure and so on, and then basing the testing on ensuring that these things cannot happen. Scenario-driven testing, again, is also related to this, to requirements-driven testing. And here it's closer to sort of an agile approach in the sense that user stories or scenarios is an intermediate step before creating test cases. So somehow you have an understanding of the requirements, can be specification, can be natural language, can be just your experience and understanding of the domain. You write scenarios or stories from that, and then the test cases are given from these scenarios. So also related to requirements-driven testing, also can be seen as a specific form or complement to requirements-driven testing. So that's why I discuss them here as a whole. This is a little bit maybe hard to see here in the video, but you can look at the slides. But this is just, I was looking around, is there some overview of requirements-based or driven testing techniques? And I found a systematic literature review. So this is a research article which summarizes all the available research on an area, right? And as you can see here, they have a table in this literature review where they summarize what kind of approach is there in the literature. So in total, they found 53 different research papers or studies that somehow uses requirements for driving the testing or doing the testing based on requirements somehow. And you can see, so 53 in total, and then you see many of the techniques have only been used one time or been studied one time, a few, 2 times. And then the number one here on top is requirements-based testing based on UML models. So you can see that this is almost half of the literature is focused on this. So you during your requirements or design, architectural work, design work, you develop some models which are high level, can be interaction diagrams, can be use case diagrams or something else. And so you are using one of the UML diagram types and processes, approaches attached to that. And based on these models, you then do some kind of automated or use some tools to help you in create test cases. So this is by far the most common. You see the second one there, model-based requirements test based on Modelica. So this is a language to model systems. So the third one is requirements testing time usage models. So this is based on a different type of model here, modeling the time. So when things happen in the system and when outside things happen and what the system does in response. And then you can use this to drive the testing and so on, right? So you see that behavior trees is also something that's been used. So in general, these are fairly close to model-based testing in the sense that you have some high-level model of what the system should do given outside input and interactions with outside systems, outside users, and then you use that to somehow structure your test case. And this can be done, you know, automatically or manually, or sort of often it's kind of in between, semi-automatically. So you get a structure of test case, and then you maybe need to fill in some details to get an actual test case. Some techniques will be more automated, but they often require a more detailed model. So that's just an overview. So you see here that what's not studied so much maybe in the literature is what's maybe the most common form in industry is that you have requirements written in natural language, in text. So no real formal model, very informal, sort of, you need a human to understand it. But then, of course, the humans can extract scenarios or write test case flows, abstract test cases, we sometimes call them. So the steps that should happen is taken or driven by what's written in the requirements. So this is a common way of driving the testing from requirements. These more formal approaches are still fairly rare, I would say. It's more common to have more lower level design models and then drive the testing from that, as you will see in part 2 of the course. Okay, so I said traceability. The traceability aspect is very important in requirements-driven testing. So what is requirements traceability? It's the ability to describe and follow the life of a requirement. So what happens to a requirement or a set of requirements as we go along in our development process, during the project. What is happening to a requirement? So are we changing it? How is it connected to the design? How is it connected to the testing? And can we follow when things change in the requirements? Can we see which part of the design and the testing that needs to change? And on the other hand, when we find problems during testing, can we then track back and update or change the requirements and see what the effect is there? So what they would say, ability to describe and follow the life of requirement in both a forward and backward direction. So these are forward towards the testing and the design and the code, and backward from these later artifacts back to the requirements. Even during deployment, right? When something goes wrong, can we sort of link the failures back to requirements and what went wrong to sort of analyze this? And by far the most common way of achieving this in practice is something called the Requirements Traceability Matrix, the RTM, which is a map from requirements to and from back to test cases. The basic goal of the RTM, the traceability matrix, is to ensure that there is testing for each requirement. This is by far the most common goal. That's how it's going to be used. So forward traceability is the mapping from a requirement to the test cases that tests this requirement. So each test case might not test the full requirement, but testing some aspect on it, depending somehow on this requirement. So how the forward traceability is often just that in the requirements document or in the requirement system, there is for each requirement, there's an entry. Here you can see it in table shape, but it can be like a web app, or many modern requirements tools have like a web-based interface. So it's basically one page per requirement, and then you can get lists like this. But you can look up one requirement, and it has a number, it has a description, a name, and then somewhere in that system, or like here in column 3 of this matrix, you can see, matrix, but list. You can see the test case identity, so the names or numbers of test cases that helps in testing this requirement. Here in this case, you also have some kind of summary of the latest time we run one of these test cases, what was the outcome. So this is forward traceability. So you can go from a requirement to a test case, and often there are many test cases to test one requirement. So you see here 3 for the first requirement, you have 6, 7 for the second one, number 3, 4, 5 there, and 4 for the third requirement here. So you get forward traceability. In some sense, implicitly, you have some kind of backward traceability. But to get backward traceability fully, you often have this more clear matrix structure. So this is something you can see in many industrial systems, especially in this sort of embedded aerospace, safety critical type of systems. Many of the standards require them to have this traceability matrix, and when consultants or certification agencies come to check on them, they will sit down and look at the traceability matrix. And probably they nowadays have systems rather than doing this manually in Excel, they can get it from the system. So they can see color coded here. When was the last execution of a test case? Did it fail? So this like going to be green or red in this matrix. And this matrix then allows both forward and backward. So backward here would be, let's go to test case on row, so the 1.1.2. So you can see it's testing two requirements. So it's requirement 1 and requirement 1.2 and 1.3, right? So now if we find a problem with when running test case 1.1.2, we can sort of relate that to the requirement and see is something wrong in the requirement, or is it in our implementation, or where should we sort of start to fix this problem. And then of course forward is easy, then we can check for each column, is there a test case and has it been run recently and so on. So very basic. If we go to risk-driven testing, this is the complementary technique. So this is a little bit different. It's not enough here to have only a traceability matrix. The first question is, what is a risk? And in engineering situations, we often talk about two aspects of a risk. So a risk is some kind of potential, it's related to a potential problem. So something can go wrong when we run the system or when the system is up and running. And the risk is to analyze the likelihood. So how probable is it that this problem can happen? And the other dimension of a risk is what would be the impact? So how severe would the impact be? So if you look at something like Microsoft Word, then one risk is that it cannot connect to printers, right? So the likelihood of this is pretty high, and the impact is probably also pretty high, because the likelihood is because people have many different printers, you have to rely on the operating system for the connection to the printer to work correctly. So the likelihood is fairly high compared to other things that can happen within Microsoft Word, for example. And the impact is also pretty big because people use word processing software in order often to, at some point, print, right? So it could be fairly problematic. So from a risk-driven testing perspective, Microsoft should spend a lot of time on testing the connection to different printers and making sure that there are no problems around this area. If you take something else in Microsoft Word, let's say that, I don't know, color coding or something which is about the formatting or layout, I mean, the likelihood is less because you have control of that inside the system itself, and the impact is probably less. I mean, people will be annoyed, but they can still do a black and white sort of document and still sort of manage their critical business or whatever, right? So the risk in this case is not as high. So from a risk-driven testing perspective, you would put a little bit less effort on this. Maybe you would do this in more manual testing rather than having lots of tests for this. Very simple high-level example and quite hypothetical, but it shows you how this is done. So in any type of risk management, there are like 4 steps. First is identifying the risks. And here in risk-driven testing, this is typically done from requirements perspective or from domain perspective. So you know about what are the critical problematic failures for this domain. And then you sort of structure your risks or find your risks based on this. So comparing sort of requirements or design of a system with domain knowledge, then you describe the risks, right? So second step in any type of risk analysis or risk management is analysis of the likelihood and the impact of each risk. So basically step 1, you fill in one column of a long list or Excel sheet, and that's the name of the risk, and you describe the risk, right? So then you will have a list of, typically, I don't know, depending on the size of the system, you will have, say, between 5, 10, for very small, up to, I don't know, 50, 100 risks maybe. So you have a table or list with up to 50 entries or rows, and now you're going to fill in 2 other columns here, and the first one is likelihood. So how probable is it that there will be a problem with this thing, the risk here. So you're analyzing the risk for this potential problem. And often this is done very coarsely, like low, medium, high, or some kind of percentage. So how likely is it? How probable is it? The likelihood. The impact is also done on a coarse scale, like low impact, middle impact, or high impact. So how severe would the effect be on the use of the system, on the surrounding things that the system can affect? What will be the impact if this problem happens? So now the risk is a combination of describe a potential problem, and describe the likelihood, describe the impact, and now this is one risk analysis, and then you go on and do this for many. Third step is mitigation strategies. What can we do to avoid this problem? How can we minimize this risk? So minimize the risk that this happens, this failure happens. How can we handle it? So depending on what it is, I mean, sometimes you can almost root out the problem, right? You can introduce so many other things so that you can totally avoid this, but this is rare. So often instead you try to minimize risks, right? So you try to handle them in some other way. And fourth step is monitoring the risk. So throughout development, and this is where testing comes in very naturally. So for the high risk areas or problems that you've identified in steps 1, 2, 3, you would now introduce lots of testing here, and that will help you monitor. But in a general risk management sense, monitoring can be other things. It can be probes in the system, it can be like runtime assertions, it can be other things to try to detect when you're going in the direction of one of these potential high risk problems. But testing here can be very important. So the risks based on steps 1, 2, and 3 will help you sort of focus your testing on the high risk areas. And this is often what is kind of unique in this one is related to negative testing. So how does the system handle invalid inputs and invalid situations or strange situations and so on? So this is quite an important type of testing, because a lot of testing techniques focus on the mainstream, the normal case, the sort of the positive testing case, this is what typically a user will do. While risk-driven testing is more about the opposite perspective. What can really go wrong? So this represents negative testing is a larger set of techniques, and risk-driven testing is one of those techniques that helps with a negative mindset. Robustness testing. Is the system robust? Can it handle the rare, the unexpected, the anomalies? So that's why it's quite a good complement to other high-level black box testing techniques. Yeah, so we already discussed this, but here's a very generic overview. So testers, when they do this, they can do risk identification up top. So they talk to the requirement staff, the technical development staff, the business staff, and they draft sort of a risk analysis, and they get feedback from everyone. Then they have a workshop with risk analysis. Then you discuss these potential problems and you assign a probability. So this is the likelihood and the impact or consequence score, right? So often you kind of do some kind of percentage on each, or you have a rough coarse-grained scale, like low, medium, high on both, and then you multiply them. So something which has a low probability or likelihood, low there, and has a low impact would be like low times low. It's basically 1 times 1, so the risk score is 1. Something which has a middle level probability or likelihood and a high maybe impact or consequence would be 2 times 3, so the risk score is 6. So it's like should focus much more on this one. And something which has very high probability situation but a low impact would have 3 times 1, so we would get a risk score of 1. So basically this is the simplest possible often, and you get a score from 1 to 9, and then basically you will do a lot more test cases for the high scoring problems or risks. Next step, risk response, so mitigation here. Formulate test objectives and select testing techniques for these different risks. So we're talking really black box, high level things here. So you might need many different lower level testing techniques to address the different risks that you've identified. And here is also where you connect the risks to, which requirements is it related to, which test cases. When should we test the different types of things? Some things can only be tested in the end. So how can we sort of still ensure quality in these risky areas so we don't have to test everything in the end, right? Fourth step in this little process is test scoping. So agree the scope of risks, agree responsibilities and budgets. So this is where you get more down in the detail. Who's going to do what and when, and often here you also have to limit the scope, right? You cannot avoid all risks. There will be some risks still left. And final one, test process definition. So then you make it concrete. How are you actually going? Then you apply the testing techniques and really define test cases to address all the different high risky areas. Okay, finally, scenario-driven testing. So we discussed requirements based testing or driven testing, focus on traceability often, many techniques, depend on how you wrote the requirements. Risk-based testing is kind of the flip side, a negative testing focus, analyze from the high-risk areas, go back and create and prioritize your testing based on that. Scenario-driven testing are related to both of them, but often is more kind of focused on positive testing. So what is a scenario? So scenario is going to be the main thing. It's a hypothetical story about the system, about the use of the system. So it helps a person to think through a complex problem or a complex system. This is the general scenario. A scenario test is a test case or specific test based on a scenario, right? So very natural. And Cem Kaner has been, he's sort of a consultant. Sometimes he writes research reports, but I wouldn't call him, he's both a researcher and a well-known consultant in this area. But he's very well known as a consultant in this, and he talked a lot about scenario-driven testing 10, 15 years back, and still is. So what are the characteristics of a very good or ideal scenario test? Well, it's based on a story. So here you can see the connection to Agile, to user stories. So it's based on a story of how the program is used, and you also include the motivation of the actors involved, right? So it can be surrounding system, but often it's a user or a set of users. So what are their motivations, right? So it can be, like imprinting in Microsoft Word. The motivation is that you need to get a report out, or you need to send off this document to some manager or customer or something like that. So that is motivating the story of printing a document. A story should be motivating. So it means that if there was a problem with something in this scenario, then some stakeholders, so some user or customer would, or even internally in the software company, development company, would push to fix the program that fails this test. So this should be this means in reality that these are high level mainstream things that really needs to work. Otherwise someone will notice and someone will say that this software is not complete or doesn't have enough quality. The story should be credible. So this means that this is focused on the mainstream, typical use, normal use of the software. So stakeholders should think that this story is probable to happen in reality, right? So this is not focused on the anomalies, the strange situations. So it's often a more credible sort of, yeah, this could really happen, you know. Story is often complex, so it's not like simple unit level type of small things in using the system. It's often like a full sequence of things, like starting a new document, writing a few headings, adding some text and a figure, and then saving and then printing a document, right? So this is quite a complex. It's testing a lot of different stuff in a single flow with real complex data. It's typically a scenario-driven test. And then still, you should use realistic data, but you want test results that are easy to evaluate. So you don't want very complex, let's say some outcome of a complex mathematical analysis. You would keep it relatively easy to evaluate. Of course, this goes for any test case, but in particular for scenario driven, because since you have the steps are complex and you're testing many different parts of the system, probably each step needs to be fairly limited so that you can judge if the system is fulfilling the scenario. So yeah, this is the type of sort of high level direction in scenario driven testing that you can find. And in Cemkanir's report called An Introduction to Scenario Testing, which is a good reference if you want to get into this some more, he lists 17 different ways to create good scenarios. You know, this is not going to be complete, but maybe you can use this as a starting point. So he did, sort of mentions a lot of different heuristics or guidelines that he have used that others have used to find good scenarios. So you can interview users about like typical flows, famous challenges, failures of the old system or that they have used. You can follow along users to see how they work today. What do they actually do? I mean, let's say you're creating some kind of database-based system for economic transactions in a company, then you would follow along some economist in this company to see what do they do, what's their common flow today. That could help you create scenarios. You can write life stories, number 9, for objects in the system, so you can look more at the data or things, abstractions of the system, what happens through its lifeline, so then you can create scenarios based on what are sort of the state changes of a document, say, or of a map in a map creation software, or of a figure in a graphical piece of software, or whatnot. Complaints, bug reports from previous systems or competitor systems, and so on. So yes. Downsides of scenario-based testing. So it's hard often to use early on in the development of system. This is high-level, system-level testing, closer to acceptance testing. So when you're during development, you can use scenarios maybe to guide you to write also lower-level test cases. So you can still, this does not mean that you cannot develop the scenario-based tests early on. You can. We can help you direct also lower-level testing, but they themselves are not enough for early testing or for testing of unfinished subsystems and so on. So scenario-based testing is better for later high-level system testing, a fairly stable system, since scenarios are complex, right? Also, it's not targeting coverage of requirements per se or structures of the system, so it's more about the use, which is both good and can be bad. So you cannot use it to ensure that you've covered the system. It's closer to requirements and real-world use. And it's not focused then on negative testing or risks. So it's a complement or different. It can be costly to write down in detail. So if you need to do this in document form, it can lead to very long test cases that can be harder, costly to maintain and so on. So maybe you need to be, prioritize your scenario-based testing quite a lot. There's also been reports that it can stifle creativity in exploratory testing. So if you have scenario-based testing or any type of high-level testing written down, people tend to stick to those rather than think clearly in every testing session. Is there something else I can do? So one general recommendation is to use scenario-based testing almost like abstract descriptions of test flows. And then you fill in specific details and data that you enter every time you run through a scenario. You can change that, right? So then you need to think in using many of the other techniques we discussed in black box testing, possibly to fill in the details, so to speak. Okay, that was it. So no quiz for this one because this is important to know about these techniques, but it's not something that we focus on in the course. So this concludes the part 1 of the course, the basics, sort of what everyone should know. There will be a little bit more in part 3, but more recent or modern techniques. So now we go into the classic sort of model-based testing. And then in part 3, we will complement with other types of model-based testing. So thanks a lot.